Okay, any questions? Let's start.
I'm just not sure about the lab for tomorrow. It's due, right? The procedure?
Yeah. I don't want to like a carbon copy of the written procedure in the lab manual.
Right.
You know, it's just too long. And there's no point in doing that. What you need to do is you need to just to get the key points out of there and come up with a shortened procedure. Much faster go through. This is just doing something like this is to build up speed in lab. So is it clear? Somebody asked me about the pre-lab at the end of the class. You don't have to do any of the pre-lab questions. Mm-hmm.
This is part of the first lecture, right?
Yeah. It's just a chromium complex. The other complexes, the copper complex, the aluminum complex, we aren't going to do. I've done those in the past for the class, but I like this one the best. Even though chromium is kind of dangerous in terms of health, in terms of reactivity, it's still a good one to do. We can keep it safe as long as people are careful. You know, when you do these procedures, a lot of people say they don't pay attention to certain things. Like, for example, do you mix the oxalic acid with the chromium, or do you mix the chromium with the oxalic acid? I mean, which one do you pour into the other? Does it make a difference? And the answer is yes, it makes a difference. You know, in general, what do we like to do? In general, we like to do things like, you know, you might remember AA, double A. Double A means what? Add acids. You always add acids. Now, that's perfectly fine for acids, but can you apply that to other things? For example, here we aren't working with acids. We're working with dichromate, and we are working with oxalic acid. Ooh, you're right. Should I be adding the oxalic acid to the dichromate because of double A? Right? Does that apply in this situation? No, it doesn't, because this is a redox reaction. This is not an acid-base reaction. Double A is for acid-base reactions. In fact, double A is for adding primarily sulfuric acid to water. But in general, what would you do, you know, in a case like this? You know, potassium dichromate versus oxalic acid. Which one should you add to which? Well, you just read the procedure. The procedure will tell you. But there's a difference. You know, there's the cookbook chemists. The cookbook chemists, they don't have to think about what the steps do. They just make sure they mix the right amounts, right? That's it. But what we need to do is we need to get out of the, you know, the formulaic cookbook method and get into the thinking method. The reason we have to do more of the thinking method is not because of this lab, it's because of the next lab. Wait, let me take it back. It is also because of this lab, because there's some procedures there that require tweaking. But in the next lab we're doing is qualitative analysis. Qualitative analysis, a lot of you have done in Chem 4. But we're going to have a very long qualitative analysis procedure. And so by the end of step 20, you know, if you were to cookbook it, by the end of step 20, you're left with nothing. You have no product left, and there are more steps you got to do. And so people come up to me, oh, I got nothing left here. You know, what should I do? Well, you know, the reason they got nothing left is they hadn't been tweaking things as you go along. You have to make adjustments, continual adjustments, as you do this procedure. And so one of the things that you got to think about is, you know, why do we have this rule, double A? You know, what's the whole reasoning behind double A? Does anybody know? Double A is so that you don't get a, what? Violent. So you don't get a violent reaction. And so when we're doing this, everybody should know potassium dichromate is a powerful oxidizer, and oxalic acid is a very weak. Oxalic acid is borderline strong acid. Nah, well, it's still a ways, but you know, it's close to the border. Do you see it, oxalic acid, on that chart? What's the strongest acid that can exist in water? Hydronium. What's right below hydronium? Oxalic acid. Is it such a weak acid? No, it's not such a weak acid. You guys remember what I was talking about last week? Did the oxidation states, all that other stuff? Anybody remember that? Raheem probably remembers what I was talking about last week, Raheem.
Okay, perfect. Hi, everybody. So